Hey guys, this video here is designed for you guys that missed the two-day activity that we did in class where we use graphs to evaluate linear rules. We did it with GeoGebra, and then we uploaded the assignment in Edmodo, and that's how we turned in the assignment. So this video is going to explain to you how we go about that process. So as we need to get things opened up, you can just pause this video, get what you need open, and then restart it or continue so we can move on. I also recommend you working along with me on the video so that you understand the GeoGebra app. But you should be, since you clicked on this link right here, you should be on this website right now. It's the Integrated Math 1 site. So underneath here, there's two files that we need to open. One is the GeoGebra file. That's this one right here. And the second one is our electronic Word document that we can work with and submit this Word document as our assignment. So let's go ahead and open both of these. It doesn't really matter which one first. Just evaluating linear patterns. You got to make sure that the computer you're on has GeoGebra so that it knows what this GeoGebra file is. If you don't, then what we need to do is, I'm going to open a new tab here, and we're going to go to geogebra.org. Okay, hit enter. We're going to go to the GeoGebra site, and we're going to click on software. Then we're going to scroll down below this little video here, and we're going to click on the Windows link here. And then we're going to just save this file, let it install or let it download, and then you're going to just run the installer. And that will get you, and you're going to do the standard install and all that, and that'll get you GeoGebra on your computer. So once you get GeoGebra on now, if you have it already on there, then we're good to go. But if you don't, you need to go through that process. So back on my site here, you've gone through, so you might want to pause the video, get GeoGebra, and then continue the video now. So you should have GeoGebra. Now we're going to click this download the GeoGebra file. So we click on our little download arrow, and we're just going to open it with GeoGebra. So now that we know that we have the GeoGebra file ready to go, it should look like this when it pops up. It has our linear patterns. Okay. The second thing on my website, so I'm going to go back to the internet, and I'm going to download the using graphs of linear patterns to evaluate blah blah blah. We're going to open that Word file. Don't click on the name because that just gives you a little view window. We have to click the download and go ahead and open this Word document. So click OK. I already have mine open. So this is what pops up when you do this, okay? So everything that I highlighted here is something that you have to look at. So green or the yellow highlight means that we have to enter some stuff here. Finish the equation and put your name here. So we have 5 equations, and you're going to evaluate a couple terms for each equation, okay? So we also, with the GeoGebra, we're going to set up these patterns here, or these equations with GeoGebra, and then we're going to paste our screenshot as we evaluate for these terms. So the assignment is 5 equations. You're evaluating 2 input values in each equation, and for each one of those inputs, you're going to use GeoGebra to show where that point is, that evaluation point on the graph. We're going to paste the screenshot on our Word document, and then we're going to finish the sentence here and say, like, the 16th term in this case is, and we're going to write what the 16th term value is. Same for like the negative 10th term value and so forth, okay? And I got instructions here too. When we do our screenshots, we want to make sure that we have both axes showing in our screenshot, because our axes are our guidelines. So we can know, when we look at the picture, we know exactly what's going on. Okay, so let's get started here. Let's grab our GeoGebra app here, and before we do a specific problem, I'll do number 1 with you, and then your assignment is going to be the rest of them, and then I'll show you how we submit it in Edmodo. First, let's just get a feel for the app here. So this is the GeoGebra app, and you can work alongside with me if you want to, or just watch me use this. But either way, know how to use the GeoGebra app. What we have is our rules that we write, our linear rules right now are in this form. Actually, let me click this button here. This bottom button, show algebra work to evaluate for output. If we click that, it actually shows the algebra for, in this, since our, by default, the GeoGebra app has the term number we're solving for, which is the n value. It's set to 0. So we're just solving for inputting a 0 into our rule and seeing what we get out. And right now we have a difference of 2. So as we go from one term to the next, we add 2. Notice our scale jumps by 2. That's why it's only going up one line, right? But as we go from like our 0th term to our first term, we're adding a value of 2, right? Next term, add a value of 2. Go to the next term, value of 2. If we work backwards, we go back a term, subtract our difference of 2. Go back a term, subtract our difference of 2. Right? So we can change our difference by either dragging the slider around, which you guys can see is changing our difference between terms. Like here is a difference of a half, so as we increase our value, we go up a half. Okay, increase our value by 1, go up a half. Increase, go up a half. So the difference here changes our difference. The D is for difference. N is the number we're going to evaluate for. And right now, the way that what we're showing, it doesn't really matter much except for the algebra shown here. The evaluation work is changing depending on what we want to evaluate. And then the B is our 0th term. So as we change that, we can make this graph cross any 0th term that we want to. So for instance, if I stop right now, what I have for an equation is a difference of a half, and my 0th term is 5. Therefore, my rule is going to be a half times n plus 5, right? In this case, n is 3. Okay, so let's just do this real quick. Let's say that I wanted to represent this rule. T sub n or y, it doesn't really matter. T sub n equals negative 3n plus 2. So to represent this equation with the GeoGebra app, I need to identify that this negative 3, and we have the general formula of our rule right here, so just always refer to this. The number that's multiplying our number that we're going to evaluate for is our difference. So this negative 3 is our difference. So I'm going to set my difference to negative 3, and you can either slide it to negative 3 or use this little input box to just type in negative 3. So I'm going to hit enter. Notice our difference as we go increase the term number, we're actually going down 3, right? So that's our difference of 3. And then we're going to add 2. All right, so I'm going to, well, our 0th term is 2, so I'm going to change my b value to 2. So now this is actually representing our number pattern here of negative 3n plus 2. Notice 0th term's 2, difference of negative 3. So now what if we wanted to evaluate for, let's find out what the 10th term would be of this sequence or this pattern here. Okay, so here's some things that we need to do. I'm going to set my n to 10. Right, which means I'm going to evaluate the 10th term. Notice the algebra here says if our difference is negative 3, we're going to evaluate the 10th term. Negative 3 times 10 is negative 30. We add that to our 0th term, so we get our 10th term to be negative 28. So we know that our 10th term, if we were to go over to the 10th term, we'd have to go down to 28. So I want to see all that work. Okay, now to understand this algebra and where this comes from, I'm using vectors to argue what's going on here. So I'm going to click on this Show Vectors Representing Rules button, and a bunch of vectors pop up, right? So let's go over to our 10th term, and let's go down and find out, it's the 10th term we know is negative 28 in this rule based off of our algebra. So let's see it graphically. The Move Graphics tool that I just used is this one right here that looks like a little compass, north, south, east, and west. Two functions of this that you need to get comfortable with. When we use the Move Graphics tool and we just hover over the plane here, the coordinate grid, it's a little hand symbol, and if you click and hold your left mouse button down, your little hand like grabs the screen and then we can drag it around, right? So since we know that we need to show our 10th term is a negative 28. I'm going to just move my axes so that I can see my 10th term and I can see my pattern moving down, but I need to keep going down. So if I were to go to my 28th term, which is right, or 10th term is negative 28, it's right here, but I lost my x-axis. So what I want to do with all my screenshots, and what you are going to want to do, is show your axes so we can always see, all right, here's my 10th term, but now I want to see more, right? So the second feature of our Move Graphics tool, if we hover over one of the axes, like the y-axis for instance, notice the little hand turns into an arrow pointing up and down. When that happens, if we click and hold and then drag the axes towards the origin, it changes our scale. So now we can, without hiding our x-axis, now we can go ahead and show the 10th term of this pattern is negative 28. Okay, so now let's explain these vectors too. There's two vector representations of really what's going on here. What I call vector addition on the y-axis is exactly what this is right here. Okay, on this app, from 0, 0, from the origin, we go up using this rule here. We start by adding 2 to our value, right? So if n is 0, we get out 2. So we go up from 0, 0, our y-intercept, or our 0th term value. Since b is 2, and our rule says b is 2, this vector right here has a length of 2, right? So now, what we know too is that our difference here is negative 3, and since difference is blue and our difference in our rule is negative 3, each of these little blue vectors going down are a length of negative 3. Okay, so we start at 0, we go up our 0th term value, in our case it's 2, and then we apply our difference of negative 3. Since our rule says here, we're going to apply our difference of negative 3 10 times, since we're going to solve for the 10th term. So notice we have a difference applied once, twice, 3 times, 4 times, 5 times, 6 times, 7 times, 8 times, 9 times, 10 times, right? So we're applying our difference of negative 3 10 times. That's what this rule says is happening when we evaluate for a term. So really, if we were to add up all these negative 3's, and there's 10 of them, don't these really have a length of negative 30? And that's what our algebra is saying right here. And that negative 30 we add to this initial value here of 2. So it takes that length of negative 30, but it shifts it up 2, since that's our 0th term. And 2 plus negative 30, we end up at negative 28. Okay? And if I were to evaluate for a different term, like maybe the 8th term, notice we don't apply as many differences, which gets us down to our 8th term. We would apply our difference of negative 3 in this case 8 times, right? So here's our difference of negative 3 applied 8 times. Negative 3 times 8, these blue vectors add up to a length of negative 24, and we add that to our 0th term 2. So we have 2 plus negative 24, so it makes us go down to negative 22. That would be our 8th term, right? So I'm going to go back to 10. So as we change these evaluation numbers, you can see how the algebra and the vector addition are really explaining the same thing. Here's a visual of what our algebra is saying, right? Now the other side of this is our vector notation that shows us how to graph the locations of each term, like the first term, second term, third term, fourth term, whatever we want to evaluate to, starting at our 0th term. Okay, so I'm going to go back to the 10th term. We're solving for n being 10. It's negative 28. So from our 0th term, we actually start at 0, 0. We go up whatever that 0th term value is. In this case, it's 2. And then as we increase term values from 0th term to the first term, that's what these green arrows are representing. We're increasing our term number by 1. So if we go from our 0th term to our first term, that's what that green arrow means, we apply our difference of negative 3. That's our sequence thought, right? So we know that our first term then, if we go negative 3 down, or go 3 down from 2, we're at negative 1. So our first term must be negative 1. Let's go from our first term to our second term. That's what the green vector is showing. And we apply our difference of negative 3 again. So if we were at negative 1 here, and we subtract 3 from negative 1, we're now at negative 4. So then we know the second term of this rule is actually negative 4, right? And if I put n at 2, look at that. Our second term is negative 4. So when we solve for the 10th term, we just apply this difference 10 times. So we keep, as we go from 0th term out to the 10th term right here, as we go over 1, we have to go down our difference. Over 1, down our difference. Over 1, down our difference. And if we do that 10 times, we are at our 10th term point, which means that from our difference of 2, we went down negative 3 10 times, and that gets us to our location, which tells us our output is also negative 28. Okay, so the vectors here, there's really two things going on here. This is just illustrating the algebra right here, and then Also, these vectors here are showing us how we graph location. So as we increase term, we apply our difference. There's the next point. Increase term number, apply our difference, next point, and so forth. So we're actually evaluating rules with a graph without actually applying the numbers. Okay, so I also want to show you what I call the n t of n vector. So this is an ordered pair. Since we're solving n is 10, this is saying show the ordered pair 10, and then its value of the 10th term, which we know is negative 28. So if we click that box, what it's doing is it's showing us how graphically we identify where that point is and what its value is. So since we're evaluating for the 10th term, we go from 0 over to 10. That's what this green arrow is showing. And then I'm going to go ahead and delete this here so that we get this out of the way. So if we go over 10, it's our 10th term. We go down, we find that point that's on that vertical line, which means this is the 10th term point. And then this dotted line is really what our eye needs to start doing. Once we find an input value, we go over to the y-axis and we find its output, which we just explained the vectors, which tells us why we get to negative 28. So the 10th term of this rule would be negative 28. Okay. So we can set up any rule we want, right? As we change rules, notice the 10th term is going to change because our rule is changing. And we can change lots of stuff around, and it changes our values. So what I want us to do is on our Word document, let's go ahead and pull that up real quick. Let's do number 1 together. We're going to represent this equation here with our GeoGebra app, and I want everything shown here. You need to have all 3 buttons clicked so that we can see our vectors, we can see where the term number we're evaluating for is at, and the algebra that explains really what's happening too. So number 1, let's do this together, and then you guys will have 2 through 5 to do, and then I will show you how we submit this on Edmodo. Okay, so number 1, we're going to graph negative 5x minus 10. We have to identify that the number multiplying our variable is our difference, so we're going to set our d to negative 5, and then this negative 10 is really our 0th term, because if we let x be 0, negative 5 times 0 is 0, and 0 minus 10 is negative 10. Hence, the 0th term that we input gave us out a negative 10. So our b value we're going to set is going to be negative 10. Then we're going to evaluate for the 16th term. So we're going to let our n be 16. So on GeoGebra, I'm going to let my d be negative 5. I'm going to let my b term be negative 10. So let's set that up. My difference, my d value, we said it was going to be negative 5. I'm just going to type that. It's easier. And our difference, we said it was going to be negative 10. Okay, so here's what this number pattern looks like, right? We want to evaluate for the 16th term, so I'm going to let n be 16. So now we can see in the algebra here, we don't even need graphs to understand algebra. If we can do this, the evaluating, we have our rule. We would plug in 16 for n, and we know that our 16th term is negative 90. So I want us to show this graphically. So make sure we have both actually showing. We go out to the 16th term. This green arrow is showing us where that point is, but it's below, right? So we're going to grab our Move Graphics tool. We're going to hover over the axis, and we're going to change the scale until our point pops up. Oh, there it is. So we can see we go from our 0th term, which in this case is negative 10. We apply our difference of negative 5. Since we're solving for the 16th term, we would apply that difference 16 times from the 0th term, which gets us down to negative 90. And that's what the algebra is showing here. Okay, so we know that the 16th term of this rule is negative 90. So now we're going to go ahead and screenshot this into our Word document. So above your backspace button on your keyboard is the print screen button. Okay, there's no vowels in it. It's just PRNTSCR. When I hit mine, just so you know in the video, I have a different screen capture program, but this is what you're going to get. When you hit print screen, nothing's going to happen until you go to your Word document and you go to paste it. So where it says in green here, paste screenshot here, if you highlight over that, we're going to paste right on top of that paste screenshot here. So highlight paste screenshot here, right click, and let's go ahead and hit paste, and your screenshot should pop up. Okay, so here's our screenshot showing our rule, or our negative 5n plus negative 10, or negative 5n minus 10. We evaluated the 16th term, and it's negative 90. And I just want you to be conscious of saying the 16th term is, and then finish up the equation, we know is 90. Okay, so we're done with the 16th term. So I want you to evaluate another term with the exact same rules. So now we're going to evaluate the negative 10th term. So we're going to go back to the GeoGebra app. I'm going to set my n to be negative 10. And now I need to go find that point. So I'm going to grab my Move Graphics tool. I'm going to click and drag so that I can see, oh, I'm going in the negative 10 direction. There is our negative 10 output. It looks like it's sitting at 40. And if we look at the algebra, our negative 10th term is 40, right? So here's our picture that shows our negative 10th term is 40. So I'm going to hit print screen again. And then you're going to go to your Word document. And we're going to paste this screenshot where it says paste screenshot here for the negative 10th term, and then highlight over paste screenshot here, right click, and let's paste that. So here's our new screenshot. We know that our negative 10th term is 40, so I'm just going to write up here, or in the yellow highlight, negative 10th term is equal to 40. And I'm done with number 1. I set up the equation on my GeoGebra app, and then I took the screenshot of each term that I wanted to evaluate for. And I also, in each equation in the yellow highlight, finished up the 16th term is 90. So I'm identifying the term number and its value. Okay? So number 2, you would just now set your difference to 7, your b value to negative 4, and then you would let your n be 5. Go find that point, manipulate your screen with the Move Graphics tool, paste your screenshot here, and finish your equation. Okay? And then do that for the negative 15th term, and then we have another equation. So there are 5 equations for you to do. Each equation has 2 terms to evaluate for. Paste screenshots, finish the equation. Okay? Now, when you get done with this, so you're going to do all 5 of them, we're going to save this file. So we're going to go File, Save As. I like Save As because we can put it wherever we want to. We can find our document, right? So you're probably going to go to Documents. You're going to save your file, whatever it happens to be. All right, so we save it. And then we need to go to Edmodo. So when you're done with your assignment, you're going to go back onto the internet. You're going to go to edmodo.com. You're going to sign in, and you're going to go to your Integrated Math 1 class, right? And that's what this is set up to do. Here, this is later, right? So I've had some extra stuff on Edmodo. So when you get on there, you're going to have to scroll down to where it says GeoGebra Follow Along. And then you're going to go ahead and click in the Turn In. Okay? So when you click Turn In, it says I already did this, but when you click Turn In, there's this little document symbol here, file symbol. So when you click on that, it's just going to ask you to upload that document. So find in your documents where you saved it and upload it. And then I have your assignment. So that is the GeoGebra assignment that you need to get done. Thanks, guys. Hope that made sense. If it doesn't, let me know, please. Good luck.